Alright, so let's take a look at the other indeterminate forms here. So these are the other indeterminate forms. There are a few more that are out there, but these are the common ones that you're going to run into. And really, all we need to know is kind of if it's weird or not when we plug in our limits, when we plug in the value that we're approaching. We'll take a look at like 2 or 3 examples here, just to show you what we need to do. So let's take the limit here. So limit as x approaches 0 from the right hand side of x ln x. So if I plug in 0 here, we get 0, and then ln of 0, we're approaching negative infinity here. So remember, we have to know what our graphs look like, know what's happening. So 0 times infinity, or negative infinity, that's an indeterminate form. So what our goal here is to turn it into a fraction that we can use L'Hopital's. So we want to turn this into a situation where we have 0 over 0 or infinity over infinity. So it's going to take a little bit of practice on these, but there's a lot of patterns that develop that you should pick up on. And of course, if you have any questions or anything, we can talk about those. So let's go ahead, and we know that we already said that was a 0 times a negative infinity. Okay, not 0 minus 0 times negative infinity. So L'Hopital's, we need to try to turn that into a situation where we could use L'Hopital's. So let's go ahead and do this. So we have the limit as x approaches 0 from the right. And what I want to do in this situation is rewrite it into a fraction. So I'm going to have ln x divided by, so if we move x to the bottom, so that's a negative power, or we just can write it like this. We could write it as x to the negative 1. That's fine. It's going to end up being the same thing. So let's go ahead and plug in 0 again. So we know 0. We already said that was negative infinity. Or, sorry. Yep. And then put 0 on the bottom. That's a situation where we can use L'Hopital's. So let me back out of here, actually. So if you graphed 1 over x, 1 over x looks like this. Okay. So let me write that. I didn't mean to erase that. So here's 1 over x. This is 1 over x on both sides. So if we're approaching 0 from the right, we're approaching infinity. So that turns into L'Hopital's. We have infinity over infinity. So now we can go ahead and we can take the derivative of both, top and the bottom. So derivative of ln x we know is 1 over x, and derivative of 1 over x should be a negative 1 over x squared. If we take the bottom fraction, flip it, and multiply it to the top, we end up with, well, we got to write the limit up. Keep it accurate. So we have, that turns into a negative x. So now when we plug in 0, we just get 0. And you can confirm that by graphing the original, so x ln x, and as you approach 0 from the right, we're going to be approaching 0. Okay? So again, it's a little weird, a little tricky, but you'll get used to it once you try a couple. So let's give a crack at this one. So plug in infinity, we have infinity times infinity situation here. So what we need to do is try to turn it into a fraction to where we're going to get 0 over 0 or infinity over infinity. So in this one, what we're going to do is we're going to take the e to the x and we're going to put it in the bottom. So we get x on top, and we get e to the negative x on the bottom. Okay, so I just move that to the bottom. And now if we plug in infinity, we get a negative infinity over, so e to the negative infinity, so e to the infinity we know is infinity. So there we go. Indeterminate, infinity over infinity, we can go ahead and do L'Hopital's. So derivative of the top we know is 1. Derivative of the bottom would be negative e to the negative x. And we go ahead and plug infinity in. We end up with 1 over infinity, which is 0. And this is probably the hardest one, or hardest type of them all. So we have this limit as x approaches 0 from the right. This should be up here. Sorry. I don't know why that's there. Of x to the x. So we have 0 to the 0 when we plug in 0. So 0 to the 0, that's kind of goofy. That's one of our indeterminates. So what we need to do is try to turn this into a fraction. And we've dealt with a problem like this before, not limit-wise, but we have dealt with taking derivative of x to the x. And if you remember the trick that we used, we need to get x out of the power. So out of the exponent, we need to pull that down. So if we remember correctly, we have natural log. So what we're going to do is we're going to have this idea. We have e to the natural log of x to the x. Okay, so that's what we're thinking. All right, and at the end, what we need to do is deal with this e. So if I rewrite this as natural log of x to the x, remember what we can do with that power. So power inside the log, using power rule, we can take that down to the front. Okay, so that turns into this. And then when we plug in 0, we get 0 times infinity, which we know we can turn this into a fraction. And we already dealt with this problem. That was our first problem we dealt with. So again, we go turn this into an indeterminate. We have ln x, 1 over x. Take derivative, because when we plug in 0, we get a situation where we can use L'Hopital's, right? We get our indeterminate. So we got that 1 over x. We got negative 1 over x squared, which we know turned into that negative x. I'll just write it out again. You're already going to have that in your notes, but that's okay. So we got negative x, which was 0. So the issue is we took the limit of x ln x, not x to the x. So we modified it a little bit by putting this ln in. So what we need to do at the end, we need to eliminate that. When we know the opposite of natural log is e. So in this situation here, in a generic situation, well, sorry, we know that this right here equals our y value. So we would have to do this to both sides, right? So this is what we ended up doing. So to get rid of it, we need to take our answer. Okay, our answer goes here because we know that this is the x ln x up in here. So that's what we solved for. So this is 0 in our problem. Okay, so e to the 0 is 1. So the final answer to this is 1. It's probably the biggest thing that people forget about these problem types is if we use the ln trick to put it to the power, put it as a power of e. Our answer, once we're done, has to go up top. Has to be a power of e. So please try to remember that. And it's going to take practice to get there. All right. So if you have any questions, please let me know, and I can go through some other versions of this, some other types where we're going to use the natural log. Okay. But if we use natural log, we have to use e at the end. All right.